here we are going to the next session, which is about some techniques in atmospheric data visualization. So there are two techniques introduced in here. The first one is masking and the second one is contour smoothing. So yeah, let's begin. So these are the libraries that we need here. And you can see some like CPAS. This is a new library here, but I think you all know this. And this is, okay, so these are the functions that used to format our plots in Matplotlib. So yeah, these are the functions. So, okay, first of all, just run these code cells to open the data set and then extract the useful data from this data set. So first of all, I want to talk about a very simple method to mask out the data from your plot. So let me show you the result first. So well, it needs a bit time to generate a plot, I think. Okay, I'm still waiting for this. If you see a star sign here, it means it is running, the code is running, and something is making it slow, but yeah. Oh, well, let me introduce the code first. Okay, so these are the codes that I need to use to generate like coastline and titles. Well, you know about these already. So let's continue. Okay, I have generated the plot in here. So you can see the 2-meter temperature actually originally contains data on the ocean, right? But in here, I cover it with a white color. So how do I do this? So basically, I use the Cartopy ocean feature, and then I set it to the white color. But the trick is in here. So C order is a parameter you can define so C order is basically the order of elements in the plot. For example, if you have a higher order of the C order, then these elements will override the elements at the bottom order. So for example, this is the default C order of some of the elements. For example, test, if you want to draw some text on your plot, it by default it will overlap on top of any other elements. So you can see the text on some, like maybe over here. If you draw the text here, you don't need to specify the C order because it automatically overrides the feature under it. Okay, so I use the C order to make this whole ocean tile overlap the contours. So to make it like, yeah, to hide the information in the ocean. So this is what I did to, this is, but this method is only used for visualization. You can do it like, if you want to mask out some data and do statistical analysis, well, you can't do it, right? This is only for visualization purpose. So in the normal way, you need to use this function to do masking. So this is a function in NumPy, a function in MA, and this is a masked where function. So I think some of you may know it because we need to use it for our data analysis. So first of all, I need a length mask data. So this is data from the length mask.nc, and you can see from the data array, it has a LSM data variable, which is length C mask. So in this length C mask, it doesn't tell you whether 1 is a length or 0 is a length, but I have tell you here. So basically, if the data is above 0.5, it can only be comprised of length. So basically, a length sigma only has 0 or 1. So 1 is defined as length and 0 is defined as the ocean of that grid cell. So not really, because part of maybe you have like 0.8 and this is like 0.8%, 80% of land, right? So yeah, above 0.5 or below 0.5. So here I want to mask out the ocean, right? So first of all, I need to tell him that, okay, I want to mask out all the data from T2N that is ocean. So this is like smaller than 0.5, it will be an ocean, right? So I tell it that, okay, I need it to be here. You can see the data array, right? This is like true, 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 and then false, false, false. It means that these are the data that is really the ocean, and these are the land grid cells. So I put this Boolean array to here, and then ask the function to mask data of T2N based on this Boolean array. So of course, you need to have the same size of these two arrays in order for this function to work, because this is a Boolean array of the size of this size, and you also need the same size for T2N so that it knows where to mask your data. Okay, I just run it. Now I have another array called, I just call it T2N masked. So this is the array. Yeah, this is the whole array. You can see, because here the true values, I mask them. I've already masked them with the function, so these are just masked, and the remaining are okay because they are net length values, so they are exist here. Yeah, they're existing here. And then I use this mask array to plot. I use this mask array to generate the color contours. So let's see the result. Yeah, you can see from here, because the values in ocean are all masked, so these are all white color. And then the land values is still here, so it shows only the land values. So this is the way to do masking, and it's actually a useful technique to do statistical analysis when you have data like sea surface temperature. You definitely need to mask out the land values, right? They don't even have land values for sea surface temperature, actually. So like this is one example to use masking.